Okay, let's solve one example for the Gauss-Jordan elimination method. Additional example for Gauss-Jordan elimination method. Okay, so for example, if we have this equation 2x1 plus 3x2 is equal to -1, and 4x1 plus 7x3 is equal to 4, and 3x2 minus x3 is equal to 0. So let's write its augmented matrix, because now there are three variables, so 2 and then 3, 0, and then you have 4, no x2 over here, so 4, 0, 7, and then for here, because there is no x1, so it will be 0, 3, -1, and its right hand side terms are -1, 4, and 0, -1, 4, and 0. So this is the augmented matrix. So for the application of the Gauss-Jordan elimination method, this method prefers to have ones in the leading variable. So what I can do is I can divide the first row by 1, and then it will be the new first row. So first row by 2, divide by 2, so it will be 1, 3 by 2, 0, minus 1 by 2, and then 4, 0, 7, 4, 0, 3, minus 1, 0. So this is the equivalent augmented matrix. So in the next step, what I will do is I will make this 4 as 0. So this is already 0. So what I will do is I will do -4 times the row 1 and then add it to row 2, and this will be the new row 2. Okay, so in this case it will become 1, 3 by 2. First row of course will not change, -1 by 2, and then it will become because I multiplied by 4, so it will be -4, then it will be -6, 0, and then it will be 2, this first row after multiplying by -4, and then row 2 was 4, 0, 7, 4, so 4, 0, 7, 4, so this will be 0, -6, 7, and 6, 0, -0, -6, 7, and 6, so 0, -6, 7, and 6, and then it is 0, 3, -1, 0. So okay, so all the terms are 0 under this leading term. So and now for the Gauss-Jordan elimination method, this first leading term should be 1. So what I will do is I will divide by -1 by 6 the second row, and then that will be the new second row. So it will be 1, 3 by 2, 0, -1 by 2, 0, then it will be 1, and then it will be -7 by 6, and then it will be -1, and then 0, 3, -1, 0. Okay, so for the Gauss-Jordan elimination method, now in the second row, this is the leading term, so everything above and below should be 0 in this case. So for this to work out. So what I will need to do is I need to multiply this by -3/2 and then add it into the first row. So what will be the row operation that will be applied? So -3/2 row 2 plus row 1. Okay, so that will be the new row 1. So it will be now written as so for example -3/2 row R2 will be what? This will be 0 -3/2 and -3/2 times 7/6. So this is a little bit complicated mathematics. 3/2 into 7/6. So -3/2 into 7/6. So it will be -7/4. -3/2 into -7/6. Okay. So it will be then plus 7/4. Okay. So 7/4. And then this will be -1. So it will be plus 3/2. And now this has to be added with in the first into the first row. So it should be the first row is 1 3/2 0 minus 1/2. So after the addition we will get 1 0, okay, and then 7/4, and then 3/2 minus 1/2 is 1. Okay, so this will be the row 1, and then the second row operation will be we will multiply this by 3. So it will be -3 R2, and then add it to the R3. That will be the new R3. So what will be that? -3 R2 will be 0 -3, and then multiplied by 3, then it will be 3 and then 6. So it will be 7/2. Okay, plus 7/2, and then it will be 3. And then if I add it into the third row, so third row is 0 3 -1 and 0. So it will be 0 0 0 0, and then it will be 7/2 minus 1 is 5/2, and then it is 3. Okay, so now what's going to happen is only the second row is not going to change, so that there is a change in the first and the third row. So first row is now this 1 0 7/4 1, and the second row is 0 1 0 1 minus 7/6 and minus 1, and the last row is 0 0 5/2 3. Okay, so this is the one. So in this way we have now zeros above this pivot position, that is the leading variable position. And now the new pivot position is this 5/2 in the row 2. So this 5/2 should be 1 according to the Gauss-Jordan elimination method. So then therefore to make 5/2 into 1, so we will multiply it by 2/5. So 2/5 row 3, that will be the new row 3. So in this case 1 0 7/4 1, and 0 1 minus 7/6 minus 1, and this will be 0 0, and then I multiplied by 2/5, so it will be 1, and then 3 then multiplied by 2/5, it will be 6/5 6/5. Okay, so at the next step now, these two values 7/4 and -7/6, these should be also 0 in the according to the Gauss-Jordan, because now 1 is in the leading position. So in order to make it 0, so what I will do is I will multiply. So for example, in order to make 7/4 as 0, so I will multiply this last equation by 7/4 and subtract. So it will be -7/4 R3 plus R1. That will be the new row 1, and then the second operation will be the 7/6 R3 plus R2, that will be the new R2. Okay, so in this case, as these two values were 0, so we can safely say that these two values will not change, because 7 by 4 0, and then it will be add, so this will remain 1 by 2 and 0, and then this will become 0 because we are multiplying by 7 by 4, so this will become 0. And how about this one? So now this we need to check, because we multiplied by minus 7 by 4, and this value is 6 by 5, and then it has to be added to 1, so we need to calculate it. Yeah, so this will be 2, this is 3, so minus 21 by 5, minus 21 by 5 plus 1, so it will be minus 16 by 5. Okay, so it will be minus 16 by 5. Okay, and the how about this one? So this will remain as 0, and this will remain as 1, and this has to be 0 because 7 by 6. So now we multiplied by 7 by 6. So for this 7 by 6 times 6 by 5, and then minus 1, minus 1. So 6 cancels with 6. 7 by 5 minus 1 is 2 by 5. So it will be 2 by 5. I hope I have not made any calculation mistakes. Okay, so now it is 0, 0, 1, 6 by 5. Yeah, I just found one mistake, which was in this here, because it was like minus 21 by 10. Okay, so I change it. So it was minus 21 by 10. So minus 21 by 10 plus 1, that is minus 11 by 10. Minus 11 by 10. So now, according to the Gauss-Jordan method, this equation is now in the reduced echelon form. Rather, it is like a kind of like a triangular form, and then we already have the answer. So for example, this equation is x1 is equal to minus 11 by 10. Okay, and then this equation is 0x1 plus x2, so x2 will be equal to 2 over 5. And then this is 0, 0, x1 and x2, and then it will be x3 will be equal to 6 over 5. So this is how the Gauss-Jordan elimination method works. So the main difference between the Gauss-Jordan and the Gauss elimination method is that in the Gauss elimination method you make only those terms as 0, only those coefficients as 0 which are below the leading coefficients. Whereas in the Gauss-Jordan elimination method, we make both upper and lower terms as 0 in the upper and lower coefficients than the leading terms in the coefficient in this method. Okay, so, and in addition, we make also all the leading terms as equal to 1, so that we can directly get the answer.